Hello, and we're going to start this video on fractions. This one's going to be a kind of a cover-all introduction to fractions. Then on later videos, we'll get into the operations of fractions, as well as operations and word problems. So, first of all, what is a fraction? A fraction is also called a ratio. A fraction is also called a ratio. Not Horatio, but a ratio. And it basically is the same thing. A fraction, and I like to tell students, think of it as a pizza. Draw a pizza, cut it into 8 sections. That's the way pizzas are cut mostly. So how many pieces of pizza are in the pizza? Well, let's go from clockwise. There's a piece, 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 and there's a piece. So there's 8 slices of pizza, 8 slices of pizza in a whole pizza. Now, I'm also going to take this same pizza and I'm just going to say, I'm going to cut it different. So I go over here and I take another piece of pizza, or take another pizza, the same type pizza, and I just cut it into 4 slices. Well, that's the same thing. This pizza, 4 slices of pizza is equal to 1 whole pizza. Now my question to you, is the pizza the same size? Yes. Okay. So if I eat half a pizza over here, how many pieces am I going to eat? If I eat half a pizza, I'm going to take my highlighter and I'm going to eat half. I'm going to eat these 2 slices of pizza. I've eaten 2 out of 4 slices. I've eaten half the pizza. Let's go over here and highlight half the pizza. So over here, how many pieces did I eat? I ate 4 pieces. 4 pieces out of 8 is equal to half the pizza. Now, why do I show students this scenario before we even get started? Because fractions can look different, but basically are the same mathematically. I can cut that pizza up into 16 slices. But if you eat 4 slices of this pizza, and you eat 2 slices of this pizza, you still have eaten half a pizza. You'd be surprised on how many people say, if you're on a diet, should you eat 2 pieces of 4 slices or 4 slices of 8 slices? And 90% of the people will say 2 slices versus 4 slices. It's the same thing. All right, that is a fraction. What I just written, 2/4. 2/4 is what we call a fraction. 4/8 is a fraction. And 1/2 is a fraction. All those are fractions. These are what we call proper fractions. Proper fractions are fractions that are bottom heavy. The number on the bottom is bigger than the number on the top. The top is called numerator. This is a numerator. And this is a kind of a review, so I'm kind of covering a lot of things at one time because this is a review. And the bottom, since it's under, it's called a denominator. Denominator. I'm not going to write all that out. Now, if you notice, 2 over 4 and 4 over 8 both equal 1 over 2 because I divided, I simplified the fraction. Simplifying the fraction means that you put it in lowest terms. 2 will go into 2 one time, 4 will go into 4 one time, 2 times, 2. So basically I took 2 over 4 and I divided by 2 over 2, which is a factor of 1, and I got 1 over 2. Same thing with the other one. 4 over 8, I divided by 4 on top and divided by 4 on the bottom, which is 1. 4 over 4 is 1, and that equals 1 over 2. So I simplified both fractions, and I got 1/2. Okay? Those are what we call proper fractions, and they are basically between 0 and 1. Okay? Most of your proper fractions are going to be between 0 and 1. Okay, well, what's the opposite of proper fraction? The opposite of a proper fraction is called an improper fraction. Improper are usually those fractions that are above 1. And when we get to integers, they're below 1 also, but we won't talk about that right now. An improper fraction is top-heavy. Top-heavy means that the numerator is bigger than the denominator, which means that it is above 1. So 3 over 2 is an example of an improper fraction. Now 3 over 2 means that it is above 1. An improper fraction is above 1. Okay, remember when I told you that a proper fraction is between 0 and 1? An improper fraction is between, I'm going to put a proper fraction is between 0 and 1. Think of your wrenches. If you buy a tool kit, your wrenches go from, I don't know, 1/4 to 3/8 to 1/2 to 9/16 to 5/8 to the 3/4 to 11/16 to 7/8 to 13/16 and then to 15/16. Okay, I might have left one out. I can't. They're going from memory. But those are all numbers. Those are all proper fractions between 0, which is a non-existent wrench, and a 1-inch wrench. A 1-inch wrench would be your next one right here, but that's between 0 and 1. These are all proper fractions. An improper fraction is above 1. Improper fraction is usually a fraction that is above 1. Okay? And you could say, well, equal to 1, that would be the same on top and bottom, and that was a property. We'll go over that in just a minute. And then there's the mixed number. Now, I tell my students about a mixed number. A mixed number, I usually tell students, is used with units of measure. You don't walk 15 halves mile. Okay? You don't walk 15 halves miles, you walk 7.5 miles. You don't use 3 over 2 cups of flour. You use 1.5 cups of flour. So usually when I tell students, when do you use a mixed number? When you have a unit of measure in the problem, or the directions specify, or you start with and you end with. In other words, somebody has got to tell you to use a mixed number. And how do you use a mixed number? You just divide 2 into 15, and whatever the remainder is, you put it over that denominator. Again, I'm not teaching you the theory behind fractions. I'm teaching you just to review over some of the things that you need to remember about fractions. Now, let's talk about what are fractions as far as decimals and percents. Well, you can convert. You can convert fractions, decimals, and percents from each other and into each other. Fractions, decimals, and percents. Before I get into, before I get into the fractions and decimals, I want to go over percent. Percent is the word that is given by this symbol. Okay? That's a percent symbol. It means percent. Percent means divided by 100 or over 100. So whenever you see the word percent or you see that symbol percent, you can take that number and put it over 100 and start your conversion. Okay? So let me just go ahead and say that right now. And then you can convert from a fraction. You can convert from a fraction to a decimal or a decimal to a fraction depending on what you change it into. What do you mean, Hubert? Well, let's say you're given 4% in a problem. 4%, you cannot use that in a calculation. Okay, you can't use it in a calculation because you have to change a percent into a fraction or a decimal. Okay, let's draw a line there. Let's take a red. I never write red. You have to change a percent into a fraction or a decimal in order to calculate it. Now, once you get it in the form of a fraction or a decimal, you can change it pretty much into anything you want to. Okay? You can change from a fraction to a decimal and from a decimal to a fraction. So, what do? Well, the first thing you do, when you see that percent symbol, you say, well, that's 4 over 100. Okay, now you can leave that as a fraction and say, okay, well, 2 will go into 4 2 times, 2 over 50, and that's 1 over 25, which is equal to a quarter. Okay? I'm sorry, 1/4. I'm having brain bubbles right now. I'm sorry. Well, you can divide it on through. You get 1 over, basically 1 over 25. I thought that was right. No. 4 will go into 4 one time. 4 will go into 25 times. Okay. I'm thinking of 25 over 100 is what I'm thinking of. Okay. Now, that's one way you can do it. Another way you can do it, and I just changed a fraction into a reduced fraction. Okay? Another way you can do it is to take 4 over 100 and rewrite that 4 with a decimal right there, because that decimal is right there on a whole number. But you're dividing by 100. When you divide by 10s, and I'm going to write this down for you. When you divide by 10 or 100 or 1,000 or 10,000, there's a trick. You count the number of zeros and you move to the left that number. So I've got 2 zeros here. So I move the decimal, 1, 2. So 4 over 100 changes into 0.04. Now that's if you divide by bases of 10. If you multiply by bases of 10, you count the number of zeros and you move the decimal where? To the right. So just to give you an example, if I multiplied 0.04 times 100, I would move the decimal 1, 2 places to the right, and that would give me 4.0. So here's 2 little, if you multiply by 100, you move to the right. or tens, hundred thousands, 10,000s, millions, billions, whatever. They got a lot of zeros in them. You can multiply by counting the zeros and moving that number to the right. And now you can change from a percent to a fraction or a percent to a decimal. Now, what do you do if you want to change from a, well, I've already showed you how to do a fraction to a decimal, decimal to a fraction. Well, let's say if I give you, let me erase some of this. Let's say I give you 0.08. Well, if my brain says 0.08, but my hand says 0.8. All right. Now, first of all, I can move that decimal, that's 0.08. I could change that and make it 8 over 100, which is 8%. So I can change from a decimal, so that's going to be 8 over 100, which is equal to 8%. So I just changed that 0.08 from a decimal to a percent. Now I'm going to change it from a decimal to a fraction. Do the same thing. Now instead of writing this as a decimal, I'm going to simplify the fraction. So what will go into 8 and 100? Well, 2 will go into both, so I'm going to divide by 2. So that's going to be 4 over 50. 2 will go into those two. 2 over 25. And that's it, because I can't change 2 over 25. I can't change that to a smaller decimal. So I've just changed from a percent to a fraction, a percent to a decimal to a percent, and a decimal to a fraction. Now, what about changing a fraction to a decimal or a percent? Well, let's go with a fraction, 1/3. Well, the only thing you can do with 1/3 is divide. So 3 will go into 1, and you better add some zeros to that because 3 won't go into 1, so we put that imaginary 0 right there. How many times will 3 go into 10? 3 times. 3 times 3 is 9. Left with 1, bring this down, you're left with 10. 9, 1, bring this down. 3, and of course you see that it's just repeating. So you put a line over that, and now I've just changed my fraction to a decimal by using long division. And now I can change 0.33, change that decimal into a percent, and that would be 33.3%. And make sure you put a line over now. I've just changed a fraction into a decimal or a percent. So you've got to make sure you can go back and forth between these fractions, decimals, and percents. I'm going to put 3 more on the next page and let you work on them, and let's see what you come up with. There are 3. There's a decimal, there's a fraction, and a percent. Now I want you to change it into whatever you can change it to. Of course, if you start with a decimal, you only got a percent and a fraction to go to. If you start with a fraction, you only got a decimal and a percent to go to. If you start with a percent, then you only have a decimal and a fraction to go to. So you should have 6 answers when you come back. So go ahead and pause the video and come back to the 6 answers we'll go through together. Okay, let's see how you did. Let's take the 0.25, that is a decimal, and I'm going to change it into a fraction. Well, that's the 10th place, and that's the 100th, So I can put 25 over 100. And that's equal to 5 will go in there 5 times, and 5 will go in there 20 times. 5 will go into 5 1 time, 5 will go in there 4 times. So I just made that into a fraction. And now I'm going to make it into a percent. So I'm going to take that 0.25 and put it over 100. That'll be 25 over 100, which is equal to 25 over, which is equal to 25%, sorry. Now I'm going to do 1/5. Now 1/5, now you can do this 2 different ways, but usually when I see something that'll go into 10, I write it as a tenth. Equals a 10. 5 will go into 10 2 times, that's 2, so that's going to equal 0.2. Because that right there is the 10th spot. So I just used easy math to do that. Or I could divide 5 into 10, or 1.0. Nothing goes into, 5 won't go into 1, so 5 will go into 10 2 times, 10 with a remainder of 0, so 0.2 is your answer there. So I've changed a fraction into a percent, a fraction into a decimal. Now I'm going to change it into a percent. Well, what is a percent? Percent means over what? 100. 5 will go into there 20 times. 20 times 1 is 20. So 20%. Or I could take this and move it 1, 2, and get 20% like that. So however you want to do it, it's up to you. Now 50. 50% is 50 over 100. 50 over 100, there's my fraction, 1 over 2. Now 50 over 100, I can change that into a decimal by saying, okay, that's 50, and then I move 1, 2, 0.5 is my decimal. So I've changed a percent into a fraction and a decimal. Now that's how you convert. That's a little bit about behind fractions. A fraction is a decimal, is a percent is a decimal, and a fraction. So make sure you know the difference between the three. When do you use them? Well, there's 2 types of problems you use with fractions and decimals for right now. One is called is of percent over 100. Okay, when do you use that? Well, I tell students whenever you're given a sentence problem. Okay, whenever you're given a sentence problem, that's when you usually use is of percent over 100. What's a sentence problem? Well, I'm going to show you that in just a minute. The other type question is when you're given a problem and you want to find the original price of something. What is the original price of the shirt? What is the original price of the meal? What is the original price before taxes? And I tell students, X plus or minus percentage X is equal to the total. So, what is a sentence problem? I'm going to put a Roman numeral up here because this is one type of problem you have with fractions. And this is other, or decimal, whatever you want to call it, fractions, decimals, or percents, whatever. 50 is what percent of 2,000? That's a sentence problem. In other words, you have a sentence and you just, that's it. There's no word problem, there's no paragraph. It's just 50 is what percent of 2,000? Okay? Okay, what percent? I'm going to highlight that with yellow. And that's going to go right there. Of 2,000, I'm going to highlight that blue of is right there. And then that leaves 50 is. So I'm going to highlight that 50 green. And that goes right here. So what I tell my students, all we got to do now is plug and chug. So 50 over 2,000 is equal to x over 100. Yellow. Green. And blue. Now again, this is a review, so probably most of you have seen this before. It's called cross multiply and solve for x. It's a little pre-algebra, and I know we're still in basic math, but you're fixing to move into some pre-algebra, so I'm going to crisscross. Now to be 2,000x is equal to 50 times 100. And what you do there is you take the 5 times 1, and then you add a 0. So 5 times 1, or 50 times 1,000 is 50,000. Okay? So 2,000x is equal to 50,000. Now you don't need a calculator, so don't reach for one. 2,000. 2,000. And what happens to those 3 zeros? Those 3 zeros right here cancel. And what is 50 over 2? X is equal to 25. So we go over here and what does this mean? Well, that means that 50 is 25% of 2,000. Question. So if you take 2,000 and you multiply by 0.25, you're going to get 50. Well, let's think about that. What's 10% of 2,000? That's not right. Something's not right. Let's check that with our handy-dandy calculator. Something's not right with that. All right, something don't feel right. 2,000 times 0.25. Yeah, it should be 1 decimal. I think I've got one off. Yeah, 50 times 1,000. I think I've got that wrong. Yeah, that's right. That should be, let's see. Let me make sure. 50 times 1,000. I think I've dropped a 0. Times 1,000 should be 500,000. 10,000. Wait a minute. 50 times 1,000. There we go. 50,000 divided by 2,000. $25. Okay. Okay, I must have done something. 50 is what percent of 2,000? Maybe I just need to stop today. $2,000 times 0.25. It's supposed to be 2.5%. And I don't know where I went wrong. I figured out where I went wrong. I didn't go, I just made 100 into 1,000. I just saw it when I turned off my, sorry about that. That's supposed to be 100, not 1,000. I think I was talking so fast that there we go. Now, that should be 5,000, there we go. And then 5 divided by 2 should be 2.5. There we go. And 50 is 2.5% of 2,000. And that's how you use these sentence problems. And hopefully, if you don't change 100 into 1,000 while you're working on the problem, you should be okay. Let's try another one. Let's try, and I need you to make sure I don't make a mistake. Let's try 3% of 75 is what number? 3% of 75 is what number? Here we're given a percent. So we're going to take that percent and I'm going to highlight that right there. Oh, I'm sorry, wrong color. We're going to highlight that yellow. Of is going to be blue. And is going to be per day. So let's plug and chug. X over 75 is equal to 3 over 100. 10x is equal to 75 times 3. Well, 3 times 75, if you got 3 people with 75 cents, 75 and 75 is $1.50. And then 225, I would assume 10x is equal to 225. Divide by 10, we can use our trick and move one place to the left, 22.5. So 3% of 75 is 22.5. And that's another sentence question. And then you can say 3% of what number is equal to 47? Let's try that. 3% of what number is equal to 47? 3% of what number is 47? So let's take our colors. Let me erase all of this. And let's go with, take our handy dandy green is, what is of is blue, and percent is yellow. Type it in or plug it in. 47 over x is equal to 3 over 100. 3x is equal to 4,700. Divide by 3, divide by 3. 3 will go into 4 one time. 3 will go into 17 5 times. 3 will go into 20 6 times. And 6. And it's just going to keep on going, I think. We'll check it with the calculator. So 4,700 divided by 3. And there it is, 1566.6666. Now, that's a sentence problem. Well, then what about the other one, Hubert? Well, I like to do the other one like with a discount or with a meal. Let's say that you go to a restaurant and you take somebody with you and you order everything. You order drinks, you order appetizer, food, and you order a dessert, and basically your total bill is $56. Total restaurant bill is equal to $56. Now, the reason I say 56 is because if I said 156, some people would have a heart attack. So, and I don't want to say 6 because then you're eating at McDonald's. So that's why I put 56 because it's kind of in the middle. All right. And you left a 20% tip. What was the original cost of the food? In other words, your appetizer, your drinks, your meal, what was the price of those 3 items? Well, plug and chug. X plus or minus 0.20x is equal to $56. Now, I'm going to use the plus. Why am I going to use the plus? Because tips are what? Tips are added, taxes are added, discounts are discounts, discounts are minus. So I'm going to use the plus, and that's going to give me x plus 0.20x is equal to 56. And this is a 1 in front of that x, so don't forget that. 1.20x is equal to 56. Divide by 1.2. Divide by 1.2, and x is going to be equal to, let's go to our handy dandy calculator, because I'm not going to make you do that, 56 divided by 1.2. So our meal actually cost us $46.67. That was the original price of the meal. Now I'm going to do a problem, and we're going to do a discount, meaning that you got something discounted off. So let's go ahead and do that. Let's say that you buy a shirt and that shirt has got no tag on it. But it's at a table, and that table says 27% off. Off means subtract. And you go up and you ask the lady, how much is it? We know we're going to ignore taxes right now. You can do taxes, but this question is not asking that. What is the price of the shirt? You know, what is the original price? And she scans it, and it comes up to be $27.80. But that's the total. So you want to find the original price. So that would be X minus, the reason we're using minus is it's what? Off. Okay, so that's X minus 0.27 times, or X is equal to 27.80. There's a 1 right here. So 1 minus 0.27 is 0.73. Divide by 0.73, and X is equal to, let's go to the calculator, 27.8 divided by 0.73. $38.08. That's the original price $38.08. That's the original price of the shirt. And that's how you use ratios, decimals, and percents.